All right, well, let's go ahead and get started. Now, we've gotten started here, and we've been drilling over the squares, cubes, and powers of 2 for the past 7 or 8 minutes. And the final score was teacher had 11. That means there were 11 that nobody in the class knew. That was not good. Noah had 14, and Maddie and Brecken combined for 9. Basically, if you're doing the math, it doesn't look pretty. The fact that there were 11 that were not known is a bad sign for Monday's quiz. So I already encouraged them to study very, very diligently. I'm going to encourage you to study very, very diligently, because as I was telling them, this is a quiz that I will give to you, and if everybody passes, including you, Gavin, we move on with life, and everything's happy. It's sunshine and rainbows and birds singing. But storm clouds and lightning and thunder and hail if anybody fails. Because we're going to take it again and again and again and again and again until finally everybody passes the quiz. So learn them so that while Noah is failing, he won, so I'm going to pick on him because it sounds slightly less realistic. Slightly. But while Noah's busy failing, you can be making lots of great grades. Okay, so make sure you study and be ready for that quiz in our very next lesson. For now, though, take out your handout. And we're going to take a look at the even numbered problems on the roots handout from last night. You did the even numbered problems. And look at the very first problem. How would we read this expression? How would we read this, Maddie? Good. This symbol means the square root of, and then we read this portion here, a to the 6th, b to the 4th, c to the 8th. What do we call this symbol that tells me we are taking a root? Think about mobs of protesters. What do they hold up? Radical signs. Anyway. Hey, maybe now you remember because there's a stupid way to do so. The stupider the way, the easier it is to remember. All right, so what do we call it now? The radical sign. What do we call this, the thing we are taking the root of, Brecken? The radicand. What is it? Radicand. And then there's a number up here. Now, we don't actually see it, Maddie, because it's an understood 2. Okay, it's the only understood 2 in mathematics. But this number, we could write the 2 if we really wanted to, Noah. What do we call this number? The index. Okay, so the index tells us which root. The radical sign tells us that there's a root happening at all. And then the radicand is what we are taking the root of. And to take the root of powers, class, we divide the exponents by the index. What was your answer for number 2, Maddie? Good. A cubed b squared c to the 4th. As we look at number 4, Noah, how would I read this radical? Good. This is not a square root. This symbol means root. This tells me which one. The understood 2 told me square root. This is 5th root of a to the 10th, x to the 5th, y to the 15th, and you got for your answer.
A squared x, y cubed.
There we go. A squared x, y cubed. Number 6, how would we read this expression, Brecken?
Cube root of negative 8, a to the 6, b to the 18th.
Good. The cube root of negative 8, a to the 6, b to the 18th. And here we've got to go through the full 3-step process of taking the root. Those 3 steps are? Sign, number, letter. We said whenever you take the odd root of a negative, you always get a negative. Odd roots keep their sign. So the odd root of a positive, like we saw here, class, was positive. We said technically, when you take the square root of a number, technically, class, you would get positive and negative. Remember? But we said for our purposes, when the root symbol's there, we're going to assume we want the principal root, which is the positive square root. So we've got to keep the sign. What about the cube root of 8, Brecken? 2, we've memorized or are memorizing that 2 cubed is 8, so the cube root of 8 tells what cubed gives 8. That would be 2. 2 cubed gives 8. And then we come to the letters, and of course, once again, we divide exponents by index to get a squared b to the 6th. Number 8, what did you get for your answer, Maddie? 17x squared y cubed? Yeah, remember the square root of 49 is 7, the square root of 289 is 17. That's one of the ones we are memorizing. Number 10, this one's kind of interesting, Noah. We've got a negative sign outside the radical, and then we're taking the cube root of a negative 27p to the 9th r cubed. We're going to start by just getting this answer. Ignore the negative out here for a moment. What do we get right here, sign, number, letter? Good. Negative, because odd roots keep their sign. The cube root of 27 is 3, because 3 cubed is 27. Divide exponents by the index to get p cubed r. That's our root, but there's now a negative sign out in front. This negative is being multiplied by the radical. It's like negative 1 times this. So we've got a negative 1 or a negative times this. Now that's going to change the sign, Noah, to give us. And there's our answer. How many figured out how to handle the double negative there? Again, the negative doesn't change this negative. It changes the negative after the root has been taken technically. Now, granted, it works the same either way, but technically, you take the root, which happens to be negative, then negative times negative gives you positive. Number 12, Brecken, what did you get for your answer?
6a squared b to the cube x.
Well, if it's just a 3, we say cubed. If there's anything with the 3, we would just say 3x. So good. 6, because the cube root of 216 is 6. 6 cubed is 216. 6a squared b to the 3x. And then number 14, Maddie. Good. Initially, when you take the root, it's just 7m to the 5th. But then it's negative times that, which makes it a negative 7m to the 5th. Any questions on 2 through 14, the even? All right, and we get all of them correct. All right, but we understand the ones, okay, you did, okay. Do we understand the ones we missed then? We understand how they should have worked. Let's go to the fractions now, and really, truly, fractions are no harder than anything else. You just take the roots of the top, root of the bottom, and then if you can, reduce at the end. Let's see on number 2, what did you get for your answer, Maddie? Good. When you take the square root, you get a 15n squared over an 18x to the 8. Now, there is one little detail, Maddie. Technically, this could be reduced. Now, that means that 225 324ths could have been reduced, but I didn't want to reduce that. I'd rather take the root first, then reduce the little numbers. Finally, our last answer should be. Say it louder, I couldn't hear you. 5n squared, okay. At first I thought I heard 4, I'm like, no, that ain't right. 5n squared over, there we go. 5n squared over 6x to the 8. Did anyone get all the way to this you noticed to reduce? I didn't figure so. How many at least got the answer that Maddie had? All right, so we're good on taking the root at least. Number 4 is kind of a weird one here. We're taking the 6th root of 64m to the 12th, and then we're going to take the 6th root of r plus s to the 18th. Noah, we need to start in the numerator. We're going to start with the number. The 6th root of 64 is 2, because we are memorizing that 2 to the 6th is 64. And here we just divide exponent by index to get m to the 2nd power, m squared, right? We're going to do the same thing here. This is not an x to the 18th. But if it were x to the 18th, we would say divide exponent by index, right? We do the same thing even though it's a binomial. We still divide exponent by index, but instead of x cubed, it's going to be r plus s cubed. Does that make sense? Do what you know to do. You know to divide exponent by index. Just do it even if it looks a little different. How many figured out just to do what you knew to do? You didn't let it throw you off. Okay, it threw you off? Or is that a hint that you figured it out? Okay. You got it. Okay, good. I'm sorry I didn't see the fingers move those 2 millimeters upward. All right, don't mean to overexert yourself on a Friday morning. It's early, I know, and you're tired. All right. Anyway, good. So it seems like we figured that out well. Good. Number 6. What did you get for your answer, Brecken?
2r squared over 9 z to the 4x.
All right, you're right about the 2 because 2 to the 4th equals 16. You're right about the r squared because 8 divided by 4 is 2. You're right about the z to the 4x because 16x divided by 4 is 4x, divide exponent by index. But the 81, you took the square root of 81. I need to say what to the 4th equals 81. And it can't be 9. Think about it. 9 times 9 times 9, 729, times 9 is like 3,631 or something crazy like that. It's a really big number. What do you think maybe to the 4th power? Something times something times something times something might equal 81. This isn't memorized. This we have to kind of figure out. Pick a number, any number. Preferably not a real big number. 4. All right. 4 times 4. 4 times 4. And we actually are memorizing 16 squared. So therefore, 4 to the 4th is 256. So apparently 4 is too big because we only wanted 81. So let's pick something smaller than 4. Okay, let's try it. 3 times 3 times 3 times 3. What's 3 times 3? What's 3 times 3? 9 times 9? Oh, so apparently 3 to the 4th is 81. So the 4th root of 81, coming back to number 6, would be 3. And again, that's not a memorized one. That's just one we kind of had to figure out through maybe some trial and error. Try some different numbers and see what it is. But be careful, don't resort to a square root when it says 4th root. Did anyone figure out that the 4th root of 81 was 3? Good job, Maddie. Excellent. Let's take a look. I'll understand how to think it through. Just try some numbers and, okay, 4 was too big. Go to something smaller. Well, I know it's not 2. 2 to the 4th is 16, so it's somewhere between 2 and 4. Well, that kind of narrows it down, doesn't it? All right, and then number 8, back to Maddie. I heard the numerator 14a squared and then I lost you on the denominator. Nice and loud. All right, good. By the way, good job not taking the square root of 16, but dividing exponent 16 by index 2 to get the 8 there. There is one comment. Thoughts, anyone? It can be reduced. Brecken? There we go. Did anyone get this fully reduced answer by any chance? No, but you caught it now, okay? How many at least had what Maddie had, 14a squared over 20b to the 8th? All right, questions at all there? Why don't you go back now and do the odd numbered problems on the handout. Go back now and do the odd numbered problems on the handout. Work quickly, but accurately. all the odds, both the top and bottom section. Quickly working through sign, number, letters. Obviously, those who have their squares and cubes and powers of 2 memorized do have a bit of an advantage here, which is the whole point in having you memorize squares, cubes, and powers of 2. To give you an advantage not just this year, but really the rest of high school. Seeing some people looking back at their squares and cubes list, that's actually okay. That's better than making a blind guess. A blind guess teaches you nothing. Having to take the time and look it up will help you learn them still. Again, it'd be better if you already knew them from lots of study that you put in over the last few days, but not a problem for you to be looking them up. Noah's got them. Be up to 2 more minutes if you needed to finish. Maddie? I'm going to take 1 more minute. need a little bit more time, Gavin, you can pause the video. We're all finished. We're going to go ahead. And let's see here. Noah was the first one done. Let's see if he got all the correct answers here. So that's what, 12 problems? 13 problems he had to work? Let's see how he did. Number 1, Noah.
A, B to the 4th, C to the 5th.
Good. A, B to the 4th, C to the 5th. Number 3, Noah.
X to the 2n, Y to the 4th, Z to the n.
Good. X to the 2n, Y to the 4th, Z to the m. Number 5.
A to the n, B squared, C cubed.
Good. A to the n, B squared, C cubed. Number 7.
Negative 2x to the 4th, Y squared.
Good. Negative 2x to the 4th, y squared. Number 9.
Negative a squared, B to the 5th, C.
Good. Negative a squared, b to the 5th, c is correct. Number 11's a fun-looking problem. Let's see how you did here.
3y squared, well, 3y to 2n minus 2n.
Fantastic job. We're going to come back and look at that one in just a moment, but it is a positive 3 when it's all said and done. Y to the 2m minus 2n. Great job. Number 13.
Negative p, a plus 2b,
To the a plus 2b.
r to the 4th.
Good. Negative p to the a plus 2b, r to the 4th. All right, and then number 15.
Negative 19, c to the m, d to the 4n.
Great job. Negative 19, c to the m, d to the 4n. How many perfect on those first 8 problems? All right, we'll take some questions here in just a moment. Actually, let's go ahead and pause it now for questions. Brecken, which one or ones do you want to see worked?
7 and 13.
Just 7 and 13. So you got 11. That's impressive. Let me address 11 just in case Gavin needs it or someone in the future watching by way of video needs this, because this one is a bit of an ugly one, but again, you do what you know to do. You know to take care of this sign last. This isn't part of the radical. You also know that the odd root of a negative is a negative. Now the 5th root of 243, we didn't memorize that. We know that 2 to the 5th is 32. But that's the only 5th that we've memorized, right? So let's just see what 3 to the 5th is. 3 times 3 times 3 times 3 times 3. Lo and behold, comes out to 243. Your lucky day. If that hadn't worked, we would have tried 4 to the 5th. If that hadn't worked, we would have tried 5 to the 5th, and so on and so forth. Fortunately, it worked. 3's the root. And then we come to the letter. And in order to take the root of a power class, we divide the exponent, 10n minus 10n, by the index 5. Well, 10n minus 10n divided by 5 is 2m minus 2n. And so Noah, you did a great job there. It sounds like all of us did a great job here. Last of all, negative times negative gives us positive, and there was our answer. And all of us got that one. Fantastic. Number 7, Brecken, coming back here, we have the 5th root of a negative 32, x to the 20th, y to the 10th. Well, odd root of a negative. And we did memorize, or are memorizing, that 2 to the 5th is 32, so the 5th root of 32 must be 2. And then we're going to divide exponent by index. That's where the x to the 4th, that's where the y squared comes from. What was your answer?
I put a 3 instead of a 2.
Gotcha. Okay, makes sense. All right, and then number 13, we had a negative, and then it was the 9th root of p to the 9a plus 18b, and r to the 36th. Again, this negative isn't part of anything right now, so you just kind of keep it. Here we have the odd root of a positive, of course, is positive, understood. Odd root of 1 is 1, because any root of 1 is 1. And then again, like before, we have to divide the exponent by the index. And this is where 9a plus 18b divided by 9 is a 1a positive 2b. And then 36 divided by 9 is a 4. Negative times positive becomes negative. And there's the answer. What was your answer?
P2. I just left that one positive, but all the exponents I changed negative.
Oh, you changed the exponents to negatives instead of allowing the entire thing to become the negative. Okay, does that make sense now? All right, let's take a look at the odd numbered problems in the fraction section. Noah, let's see how you did.
Negative 2x cubed y squared over 4m into the 5th. No, that's 4.
Having a hard time reading his writing. Where was your negative, by the way? Good. Move the negative out in front, and then we get that 2x cubed y squared over 4m n to the 4th. Thoughts, Noah?
Reduce to a half.
It could reduce to a 1/2. Doesn't sound like you had the 1/2. Maddie, are you perfect so far? You were perfect. You missed this one also. All right, and he already was not perfect. So I'm gonna not hold the reducing error against you here, since she also missed that, and we'll allow you to continue for the candy. But had she gotten it, I would have given the opportunity to her. All right, so number 3, Noah, we're still with you.
13r to the x negative y over 16x to the 5th.
Fantastic. 13r to the x negative y all over 16x to the 5th. Great job. Number 5.
2m over x negative y squared.
Great job. You end up discovering that 2 to the 7th power is 128. So the 7th root of 128 is 2, hence 2m over x minus y quantity squared. Suppose if you really wanted to, you could say x squared minus 2xy plus y squared and get your perfect square trinomial. Y. I'm lazy. X minus y squared is good enough for me. Number 7, Noah.
3a to the 4th b over 2x cubed y itself.
What happened to those negatives, Noah?
They turn to positive.
There's 2 of them, and 2 negatives in a fraction always cancel. So you cancel those before you even get to sign number letter, hence left with positive 3a to the 4th b over 2x cubed y to the 7th. Fantastic job. And for the candy, Noah, what did you get on number 9?
Negative 3a over 4b to the 9th.
Good. Negative out front, I assume. 3a over 4b to the 9th is correct. Great job on that. Maddie, were you perfect other than the reducing error? So you had another issue somewhere in there. Which one? Number 7. Do you understand it now, or do we need to see it worked? Gotcha. Does that make sense, though? All right. So going way back to the fraction rule, before we do anything else, hey, I see 2 negatives in a fraction. Let me cancel them real quick. Because, Maddie, they were both in the radical. Had one of them been outside the radical, we don't necessarily cancel it. Because outside versus inside, they're almost separated like a grouping symbol, the radical groups. But they're both inside the grouping anyway. Go ahead and cancel them. But that was your only mistake, other than the reducing? All right. Brecken, how did you do in the lower section? Missed 5 and 7. Was it the 2 to the 7th being 128?
I just didn't do that one because you said I had a minute. So.
Gotcha. So you skipped that one. Does it make sense how to figure that one out, though? You're like, well, I didn't memorize anything to the 7th. But remember, we'd memorized 2 to the 6th and 64, right? So 2 to the 7th just is one more 2, and there's your 128. So even though we didn't memorize this high, probably can figure it out pretty easily there. All right, and then you said number 7 as well? On 32. So you had 3 for 243 and 3 for 32. And it makes sense that 3 to the 5th can't be both 243 and 32 at the same time. So just a little learning curve there. All right, let me go ahead and collect those handouts from you. And let's take a look at a new type of word problem that uses systems of equations. Go and collect those from you. And go ahead and read the word problem for us, if you would, Brecken, nice and loud.
A grocer sold 2 cartons of raspberries and 3 cartons of cherries to one customer for $9.60, and 3 cartons of raspberries and 2 cartons of cherries to another customer for $9.90. Find the price of each per carton.
How many unknowns do we have in the problem, Brecken?
2.
And what are the 2 things we're trying to figure out? Good, the price of raspberries and cherries. Not the number of raspberries and cherries, right? That agreed? We know the number of cartons, so whatever. We just don't know what the price is for each. So for my raspberries, doing this with me on your paper, and for your cherries, it's the price per carton that I'm trying to discern. And since I don't know the price per carton, I could say for raspberries class, the price per carton is X. And since I don't know the price per carton for cherries class, I could call that Y. But I know this. If I buy 2 cartons of raspberries, and each carton costs X, how much money does it cost just for those 2 cartons of raspberries? 2x. Furthermore, if I buy 3 cartons of cherries, and each carton of cherries costs y, how much do I spend just on the cherries? 3y. But I went and bought 2 cartons of raspberries and 3 cartons of cherries, so how much money is that? 2x plus 3y. Now again, these are not like terms, so we can't combine them, right? But 2 cartons of raspberries and or plus 3 cartons of cherries. And the problem tells us that if you bought that much stuff, your bill's going to run you $9.60. Do we see how to set up a problem like this where it's the price that's unknown, but the quantity is certainly known? At your seats, try the second equation, because another customer comes through and buys the exact opposite. 3 cartons of raspberries, 2 cartons of cherries. Cost that guy $9.90. Write the equation for that. Brecken, when you've got it, tell me what you wrote.
3x plus 2y equals 9.
Y'all got the same thing? In other words, this is pretty intuitive. I showed you one time, and you're like, oh yeah, this makes total logical sense, doesn't it? That's the beauty of systems of equations. Trying to work this without a system would be a nightmare. We've worked some problems that frankly we've done without systems in the past. For the first time, we come to a problem that really without a system of equations, really, really challenging to solve. But this isn't bad at all. We pick a variable to get rid of, Noah. Speaking of get rid of some, anyway. Noah, what should we get rid of, x or y? The x, and to get rid of the x, multiply the? What does the top equation become, Noah? The rest of you working with us.
6x plus 9y equals
Good, $28.80, okay. And the bottom equation by the 2.
6x plus 4y equals 1980.
From here, we need to do what, Maddie? Good, I would change the signs in the bottom where the smaller numbers are. That'll allow the x's to cancel, giving me how many y's, Maddie? And 2880 minus 1980 gives us $9. $9 even. And of course, we got to divide that by 5. Anyone, when you divide $9 by 5, what do you get? $1.80. So apparently that's the cost for a carton of cherries. How do I go back now and find out how much it is for a carton of raspberries, Brecken? Which one? Pick one. Top. All right, so we plug in $1.80 here. So we need to multiply $1.80 by 3. Go ahead and do that very quickly. $1.80 times 3. $5.40, but we're going to move the positive $5.40 to the other side as a. And when we subtract, it's going to give us $4.20. Now we need to divide that by 2 because that's 2x that equals the $4.20. Divide by 2, get x is equal to? $2.10 for the carton of raspberries. Questions on this system of equations, a little different from what we've worked before, and I do just barely fit that all on the screen. I didn't realize I was so close to the edge of the camera. All right, questions on that? All right. Well, let's go ahead and I want to preview what we're going to get into more. We're supposed to get a little further, and I think we spent a little too long reviewing before we started recording. Sorry, Gavin. But I want to preview what we're going to get into in our next lesson, and that's a concept called fractional exponents. Go ahead and get this down in your notes. Fractional exponents. Now, to be frank, the thought of it is usually slightly terrifying because we're like, okay, exponents can be complicated enough, and now we're going to make them fractions. But it's really not as bad, perhaps, as you might initially think, if you remember one important detail. Fractional exponents. Remember, to take the root of a power class, we divide the exponent by the index. So for instance, if I have the cube root of a to the 6th, Maddie, that equals a squared. And you got a squared because you said a to the 6 divided by 3, correct? You didn't write it out, obviously, but mentally you thought 6 divided by 3 is 2, correct? We could do the same thing, though, showing it with a fraction bar, because, of course, we know a fraction bar means division, right? We could say this is a to the 6/3, which, of course, is a squared. But what if it didn't work out evenly? What if, for instance, we had the cube root of a squared? Well, can you divide 2 by 3 evenly? No. But you can divide 2 by 3 if you'll do it this way. A to the 2 divided by 3. And unfortunately, unlike 6/3, which becomes a nice easy 2, your 2/3 just stays 2/3. And so that's essentially how we would get a fractional exponent. Write this down with a star next to it. A fractional exponent indicates a root. Fractional exponent indicates a root. So when you see a fractional exponent, you know you're literally looking at a root there. A couple things to jot down. First of all, realize that the numerator is simply the old power or exponent. The numerator is the power or the exponent in the situation. And the denominator represents the root or the index. Again, we know that to take the root of a power, divide the exponent by the index. So obviously the numerator is the exponent and the denominator is the index. So that if I had this expression, x to the 4/5, this is my exponent or my power, this is my index or my root. So this means the 5th root of x to the 4th power. Does that make sense? The 5th root of x to the 4th. And that's really all there is to it. Conversely, if you had something like the 7th root of m squared, you would simply make the power, your numerator, divided by the index, 7. And we can go back and forth with this. That's what we're going to work on in our next lesson together. After, of course, we take that quiz I've been promising you. Your homework for this weekend is to do page 278. Page 278, the review, numbers 1, 3, 5, 6, 9, and 10. Page 278, the review, numbers 1, 3, 5, 6, 9, and 10. The review has nothing to do with what we've been working on lately, okay? So no radicals and exponents and stuff. Just kind of a recap of some things we've talked about over the last couple of months. And really throughout the year. There's some older stuff on there as well. Good review homework assignment for us. Don't forget also, study for the quiz. Spend some time drilling, and don't wait till Sunday night to do it. Don't put it off till Sunday night in cramming, or worse yet, Monday morning you walk in, oh yeah, that's today. Spend some time studying. All right, you are dismissed. Have a wonderful rest of your day and a wonderful weekend.